Number 20 is about factoring. You need to know how to factor and factor well. First rule of factoring is always look for a GCF. So the greatest common factor between these two terms is 4, an A and a B. They both have a 4, an A and a B. When you factor out of 4AB from 8AB squared, you would be left with 2B. And a 4AB from 4AB, you would be left with 1. So that is the factored form of that. This is a simple trinomial. The way I do it, I know Mr. Belkin would do it at a crossbar. I do what multiplies to negative 21, the last number, and adds to the middle number 4. And that would be a positive 7 and a negative 3. And you can do that in any order. This is also a trinomial. You can look to see this is actually a perfect square. This is a perfect square, and this is double those square roots. So this is actually known as a perfect square trinomial, which means that you would have 5x and 5x, and then a y and a y. And if you FOIL this back out, the middle would become 10xy. And so another way to write that would be 5x plus y squared. This is a difference of two perfect squares. So this was a perfect square trinomial. This is a difference now. Notice it's missing that middle term. To factor a difference of perfect squares, it always is a binomials. The square root of 9c squared is 3c. That goes here and here. You put a plus and a minus. And then the square root of 49d squared is 7d. 7d, and that's your answer. 3c plus 7d. 3c minus 7d. So this looks like a trinomial, but I can see they all have terms that are common. So we got to factor out the greatest common factor, which would be 3x. And you would be left with x squared minus x minus 30. And then this trinomial is just like what we did up here. We're going to say what two numbers multiply to negative 30, but add to a negative x. So negative 1. So it'd be x minus 6. And x plus 5. Obviously, don't forget to bring down that 3x. That is important. So these are your factored form. Again, let's look to see. There's no greatest common factor, but there is a number in front of this trinomial. So the way I do it is you have to say what multiplies to these two numbers. This 3 times this 32. So 3 times 32 is 96. What multiplies to 96 but adds to the middle of 28. And then I do it like this. I put x and x because it's going to make x squared. And then the two numbers multiplied to 96 but add to a positive 28 would be 24 and 4. And they'd both be positive. But because this has a coefficient other than 1 in front, you have to divide both of these by 3. If this had up here, like this had a 1, dividing by 1 wouldn't make a difference. But because it has a coefficient of 3, you have to divide both of those by 3. Now, if it can reduce it. So 24 divided by 3 is x plus 8. And then this one, you would bring the 3 in front of the x. So 3x plus 4 plus 4. For terms, we usually look to see if we can factor by grouping. So we're going to group these two and then these two. So what can I factor out GCF-wise from these two? Would be an x squared, and I'd be left with x plus 5. What can I factor out from these two? Well, I can factor out a 2, but since it's leading with a negative here, you want to factor out a negative 2. And you'd be left with, oh, look at that, x plus 5. And then you regroup it. So you would write x squared minus 2, factoring out the x plus 5, and that would be the factored form. Let's do this trinomial like we were doing up here before. There's a number in front of x squared, and it's a trinomial, so we're going to say, all right, what multiplies to negative 18 but adds to 7? And again, this is how I do it. So I put my x and my x here. Two numbers that multiply to negative 18 but add to 7 would be a positive 9 and a negative 2. But because there's a 6, I divide by 6. And then if I reduce it, this would reduce to 3/2. So I'm going to, here, I'll write it for you. I'm going to take that 2 and bring it in front of the x, 2x plus 3. This would reduce to 1/3. So I'm going to take that 3 and put it in front of the x and then bring the 1. So 2x plus 3 times 3x minus 1. So this is two terms again. Is it a difference of two squares? No, but they do have things in common. So let's factor it out, the x and a y. You'd be left with 16x squared minus 81. And then this is a difference of two squares. Difference of two squares always breaks down into two binomials. This would be 4x, this would be 4x, a plus and a minus, and the square root of 81 is 9. And then that is your factored form. Always bring down what you factored out in front. Now this says x to the fourth, but it's a trinomial. So you treat it like you would the trinomials up here. We know it's going to break down into two binomials. But instead of putting x and x, what would multiply to x to the fourth? It would be x squared and x squared. And then the two numbers that multiply to negative 45 but add to negative 4 would be a negative 9 and a positive 5. Oh, but wait, this is factorable. This is a difference of two squares. This breaks down into x plus 3 and x minus 3. This can't break down, so you're going to just bring it down. And that is the factored form. Okay. This, I gave you a hint, is a perfect cube. You're not going to have a lot of perfect cubes, but you need to be aware that they happen. Perfect cubes are in the form of a cubed plus b cubed, a cubed minus b cubed, where you look at this term, it's two terms, and these are both cubes of something. So you have to know what's the cube root? What is being cubed? So 8x cubed would be 2x. If 2x times 2x times 2x, 2x cubed, you would get 8x cubed. What times itself again makes 125? Well, that's 5. So now we're going to follow this formula right here. This says if you have an a cubed plus a b cubed, the first term is a plus b. There's my a, and that's my b. Those are the cube roots. Then you write a squared, so take 2x and square it. That would be 4x squared. Then you put minus, multiply a and b together. 2x times 5 is 10x. And then put plus the b squared. 5 squared is 25. And that is how you do a perfect cube. If I had put a minus here, you would just follow this formula. All right, and one more trinomial. So once again, it has a number in front. I'm going to multiply what multiplies to 108, but adds to the middle of negative 31. And since this has an a squared and a b squared on the back end, I'm going to write a, then I'm going to put a b and a b. Then I'm going to 27. But again, because there's an 18, you're going to divide both of these by 18. And you're going to want to reduce the fraction. So this is 2/9 b. And this is 3/2 b. Now, bring the 2 in front of the a and bring the 9 in front of the a here. So your final answer should be 9a minus 2b, and then 2a minus 3b. Okay, now factoring. Why do we do factoring? Well, it's important to know how to solve. So we are going to solve each equation by factoring and include all solutions that are real and imaginary. So we'll start with this one. This is a trinomial again. What multiplies to negative 60 but adds to negative 11. And that would be, put your x, that would be positive 4 and a negative 15. But because there's a 20, divide both of these by 20. And then reduce and bring that bottom number in front of the x. So this would become 5x plus 1. And this would become 4x minus 3. And then since we're solving, we set each one of these equal to 0. So 5x plus 1 equals 0, and 4x minus 3 equals 0. And you get x to be negative 1/5, or x could be 3/4. These are your two solutions. For this one, it is not set equal to 0, so we're going to need to set it equal to 0. We're going to set this equal to 0, so 2x cubed minus 12x squared plus 18x equals 0. They do have something in common, so we're going to factor out a 2x, left with x squared minus 6x plus 9. And then this trinomial can factor into an x minus 3 and an x, another minus equals 0. And then you're going to set each one of these equal to 0. Well, you would end up with x equal to 0, and then these two would be the same answer, which is 3. And those are your two solutions. All right, last one, set it equal to 0. 3x squared and a minus 4 equals 0. We're going to factor this. Even though it's to the 4th degree, we can still factor this trinomial. This would be x squared. 4 times 1 multiplies to negative 4, but adds to 3, plus and minus. Now, this can factor further into x plus 1, x minus 1. And then this x squared plus 4 stays in front. Now you have to set each one of these equal to 0. X squared plus 4 equals 0. X plus 1 equals 0, and x minus 1 equals 0. These two are easy to figure out zeros. So you'd have 1 and negative 1. This one, you would get x squared equals negative 4. You take a square root. The square root of negative 4 is actually imaginary. It is 2i. And because you took a square root of something being squared, you need plus or minus. So you actually have 4 answers here. 1, 2, 3, 4. Plus or minus 2i and plus or minus 1. And now we will do the back side. Solve by the quadratic formula. You need to know how to do the quadratic formula. You should know it by heart by now. Negative b plus or minus. This is your a, this is your b, and this is your c. So it'd be negative b, so negative 6 plus or minus the square root of b squared, which is 36, minus 4 times your a and times your c. And it's all over 2 times a. Now you want to clean up what's underneath the square root. So that'd be negative 6 plus or minus square root of 60 over 4. And then square root of 60 can reduce down to be 2 radical 15, 2 square root 15. So we're going to write it like that. Negative 6 plus or minus, 2 square root 15 over 4. And then these numbers on the outside are allowed to reduce. You can't reduce with what's underneath. So divide each one of these by 2. Your final answer would be negative 3 plus or minus the square root of 15 over 4. And you can leave it like that. 36 is a little bit of a word problem, but it's not that hard. It's using quadratic formula. Normal systolic blood pressure is a function of age. For a woman, the normal systolic blood pressure in millimeters of mercury is given by the function P equals 0.01 x squared plus 0.05 plus, this is actually 107. It got cut off. Where x is the woman's age. Use this function to find the age of a woman whose systolic blood pressure is measured to be 121 of mercury. This 121, a lot of students think you plug it in for x. That's not what x is. X is the woman's age. 121 millimeters of mercury is the systolic blood pressure. That's what P is. So you're going to set this 0.01 x squared plus 0.05x plus 107 equal to 121. And then you're going to set that equal to 0 and do the quadratic formula. 0.01 x squared plus 0.05x minus 14 equals 0. And then this is your a, b, and c. So when you go to write it in quadratic formula, negative b, negative 0.05, plus or minus the square root of b squared, which is, I believe, 0.0025, minus the 4 times the a, which is 0.01, times the c, all over 2 times 0.01, which is 0.02. And then you're going to get this answer underneath here, and you're going to take the square root of it, and you actually end up with negative 0.05 plus or minus 0.75 over 0.02. You have 2 paths to go to find your final answer. You're going to type in your calculator, negative 0.05 plus 0.75, and then divide that by 0.02. And then you're going to do negative 0.05 minus 0.75 divided by 0.02. The positive route will give you 35. the negative route will give you negative 40. You do not want to choose negative 40 since we're talking about a woman's age, which is X. So choose 35 as your answer. Okay, and last but not least on this video is simplifying fractions using this idea of factoring. So real quick, let's go over how to do this. You want to factor as much as possible and then simplify. So here is a trinomial. I can take out a 5 from each of them. X squared minus 8x plus 15. And then this trinomial can be further factored into 3 and, let's see, minus 3, minus 5. And on the bottom, you can factor out a 5. And again, you can cancel anything from top to bottom, so that would go away, the 5s would go away, and all you would have left is the x minus 3, which is your final simplified answer. 38, so you're not going to do as much factoring here. You're going to make this into one fraction. That's what simplify means for fractions. So your common denominator would be both of these, x plus 2, x minus 3. And if this needs a denominator of x plus 2, x minus 3, what's it missing? Well, it's missing the x minus 3, so that's what you need to multiply this by, and you need to distribute it out, 5x minus 15. This fraction, if I want to make it this common denominator, is missing the x plus 2. I want to distribute that out. And then you want to clean up that top. You get 3x squared plus 11x minus 15. And you don't have to FOIL the bottom. We can leave the bottom as is, but that is the simplified form. You could do the same thing here. What I'm noticing though is this is actually contains an x minus 2, so I might reduce it first. This actually, I can factor out a 3, and those x minus 2's can cancel. So really I'm just doing 2x over x plus 5 minus 3. So the common denominator would just be x plus 5. And so the 2x already has an x plus 5. But the 3, remember this is like 3 over 1. In order to make it have a denominator of x plus 5, I need to multiply it by x plus 5. So that top would be 3x plus 15. Noticing I'm putting it in a parenthesis because I have to distribute that negative through. So if I distribute that negative and simplify, I would get negative x minus 15 over x plus 5. No, you cannot cancel these x's. This is a binomial. This is a binomial. You cannot cancel unless you have the same binomial top and bottom. Number 40, again, all about factoring and all about cross-canceling with fractions. So this top 2x minus 14, you can factor out a 2, and you're left with x minus 7. This bottom factors into x plus 3, x minus 1. This x squared plus 5x plus 6 is x plus 2, x plus 3. And this factors into x minus 7, x plus 2. Now again, fraction-wise, you can cross-cancel. You can also cancel top to bottom of anything. So your final answer is just the 2 over the x minus 1. With division, it's pretty much the same thing as multiplication, except you have to do change this and flip this. That's the fraction rule, same change flip. So you would have 2x minus 5, 3x plus 1 times, you're going to flip these two. So I'm going to write this on top, but I'm going to write it in a factored form. So this factored out would be a 5 times 3x plus 1. This top factored out would be 2x minus 5 times x plus 1. And again, you can cross-cancel anything from top to bottom or crisscross, and your final answer is 5 over x plus 1. Last but not least, we've done something similar to this on the other video. When you have a fraction within a fraction, you want to find a common denominator, top and bottom, and multiply the top and bottom by it. So it looks like y squared is the common denominator for both the top and the bottom. Distributing y squared, you'd end up getting The y and the y squared would reduce to just leave you with an xy on top plus 3y squared. The bottom, y squared times x squared over y squared, would just leave you with an x squared. And then y squared times 9 is 9y squared. Now, you can try to factor out something on top. The only thing that is factorable is a y, and that will not help you reduce this. So this actually, you can leave your final answer like that.